Hello and welcome to Mclean 360. In this video, I want to solve a problem with you to illustrate the concept of resolution of forces. Alright, but before we do that, let's read the problem and solve it together. Alright, so knowing that alpha is 40 degrees, we should determine the resultant of the three forces shown. Alright, so I have a 60-pound force right here, 80-pound force, and 120-pound force. And then I've been asked to find the resultant. This alpha here, they are saying is 40, as well as this one is also 40. So how do I go about it? The first thing to do is to come up with a convention. Alright, so come up with a convention. And the convention is that every force towards this is positive, and every force in this direction is also positive. So along the x is positive here, along the y is positive in this direction. Any other force which is not conforming to this is negative. All right, so let's start with the 60-pound force. So 60-pound force. Let's start with this guy. So considering the 60-pound force, what can we see? So with the 60-pound force, but before then, let's look at this. You see, this inclined plane is actually having an angle inclined at what? 20. So interestingly, what this means is that if I draw a horizontal line here, okay, what happens is that since the inclined plane makes an angle 20 here, and then the 60-pound force is along the inclined plane, then it's also going to make 20 degrees. All right. Now, once I've been able to do this, then I will just resolve this force into x component and then y component. All right. So the x component of this force is going to be 60. So fx, let me put it this way, 60 cosine 20. And then the y component is going to be 60 sine 20. All right. So with the s component, I'm going to get 60 cosine 20. And what is that? 56.382. So 56.382 pounds. Okay. And then the y component. So the y component is going to be sine. What is that? So 60 sine 20, and that is 20.521. So 20.521 pounds. Okay, good. So we are done with the 60-pound force. All right. So now we want to do the 80-pound force guy. All right. So we want to look at this guy. Now, we were told that alpha is 40 degrees. And if alpha is 40 degrees, then what this means is that this 80-pound force is making an angle which is 40 plus 20, so 60. Okay, so now ignore the 60-pound force. Let's look at the 80-pound force. And so the s component is in this direction. And the y component will also come this way. So this is going to be positive, of course, because obviously it's conforming to what we have here. So the s component is going to be 80 cos 60, and then the y component is going to be 80 sine 60. All right. So what is fx then? Fx is going to be 80 cos 60. So 80 cos 60. What is that? 80 cos 60 is 40. Okay, so 40 pounds. And then 80 sine 60 is what? So 80 sine 60. And what is that? I'm going to get 69.282. 69.282 pounds. Woo. So I'm done with the 80-pound force. Now the last guy to look at is the 120-pound force. All right. So with respect to the 120-pound force, Let's do something interesting here. Let's try to extend the line of action of the 60-pound horse. Let's try to extend this line of action here. By doing this, if the angle here is 20, then we know that vertically opposite angles are the same. So here also becomes 20. It is also interesting to note that the line, so this line here, this line here, so this line right here is actually making a 90-degree with the plane. Okay, and so the whole angle from here all the way to here is 90. In other words, we are looking at perpendicular and then parallel to the plane. So the angle there is 90. Oh. So having known that that is 90, what is alpha? We know alpha is 40. Oh, then that is it. So we can actually find this small angle here. And what is that? I have 20, I have 40. What should I add to get 90? Yes, you are right. So the answer is 30 degrees. Therefore, I'm going to use the 30 to resolve this 120 into x component and then y component. So having known that's 30, let's clean everything here. All right, so this is what I want to do. I want to resolve this 120 into x and y component. So 120 pounds, okay, 120 pounds. All right, so it's going to be, so the x component is going to be 120 cosine 30. All right, and what is that? So 120 cosine 30. 120 cosine 30. Okay, and what is that? 103.923. So 103.923 pounds. Very good. So that is the x component. How about the y component? So the y component is going to be sine 30. So 120 sine 30. And what is that? In fact, sine 30 is supposed to be half. All right, let's check. Let's be sure. Yeah, so half of it, which is 60 pounds. Okay. But you see, no, wait. We said every force to this side is positive and every force to this side is positive. Now here I have a force which is coming down, you know, because of the direction of the 120 pound. This guy is coming down. And for the fact that this guy is coming down, I have to negate him. And so this is going to be minus 60. All right. So at this point, let's sum forces in the x direction. So I want to sum all the forces in the x direction. So I'll look at this first one, which is 56.382. Yes. And then I'll add it to 40-pound force. Finally, I'll add it to 103.923. And what is that going to be? So I'm going to add all the forces along the x. So 56.382 and then plus 40 and then plus 103.923. And what is that? But that is going to be 200.305. So 200.305 pounds. All right, and then I will add all the forces in the y. So summation of forces in the y, and every force going up to be positive. This one, every force going here was supposed to be positive. All right, so what is it? I'm going to add all the forces in the y. So first of all, 20.521. So 20.521. Then I'll add it to this y component, which is plus 69.282. Then I'll add it to the last component, which is minus 60. And so I'm going to get, so let's add it together, 20.521 and then I'll add it to 69.282, then minus 60. Okay. Having done this, I'm going to get 29.803. So 29.803 pounds. All right, so that is your force in the y direction for you. Having gotten to this point, what would I do? Okay, so at this juncture, what I want to do is to find the resultant. And to find the resultant, I can use the Pythagoras theorem, which says that the square of the resultant is going to be the sum of the force in the x squared plus the sum of the force in the y squared. Okay. But to illustrate this, what this means is that I have a quadrant here, and then the x is here. So let's say this is my x and this is my y. I have 200.305 along the x, and then I have that is 29.803 here. And so the resultant is this one. And that is what we are having here. So the resultant is going to be the square root of the x component, which is 200.305 squared plus 29.803 squared. And what is that? And that is going to be the square root of 200.305 squared plus 29.803 squared. And what is that? I'm going to get 202.51. So 202.51. So 510. Okay. Pounds. And let's say the angle right here is the angle that the resultant makes with the positive x-axis. And this angle is going to be tan inverse of 29.803 divided by 200.305. And what is that? I'm going to get, so tan inverse of 29, so 29.803, and I divided by 200.305. And what is that? I'm going to get 8.46. 8.463. Ooh. So that is my angle right here. So that is it. I have my angle as well as my resultant. Okay. So thank you very much for watching.